Morning to all. We are going to see the BARC paper, BARC model questions. You can prepare similar to 1 mark gate questions. You can also prepare like UGC net if you have questions PYQs. They are also good for this standard. Only exam paper is similar to this model, exam paper. But interview is purely opposite, not easy at all. Interviews you should have different agenda. Choose 4 to 5 subjects. Of course, you can prepare all the gate questions, but choose 4 to 5 subjects. In that, you have done already gate preparation, right? And also prepare at least one textbook for them, so that all the proofs and all the important concepts you will cover them. Follow the gate, but you follow the one textbook to see the in-depth concepts of each of the statement. This is how you do. Exam paper is fine, like you just go straight forward questions from 1 mark or up gate questions, or you just select PYQs if you have them, that would be sufficient. Yeah, Shali, good morning. Shashi, good morning. Yeah. Sorry, today I'm not well, but still we will take. Construct a DFA for language L that is not contains more than 3 A's, 3 consecutive A's. Yeah, question is slightly confusing. W contains not more than 3 A's. Hence it can contain not consecutive 3 A's. This mentioned the count. It can have 0A, 1A, 2A, 3A, but not more than that. The number of A's can be 0 or 1 or 2 or 3, but not greater than 3. Without construction also you can do. It's not about consecutive A's, it's about W contains maximum 3 A's. That is not more than 3 A's, means maximum 3 A's. We solved this number of A's in a W is maximum 3. So the given sigma I comma p. How many states you will require? Please answer it. Zero A, 1A. It's very easy to answer. 2A you should accept. 3A you should accept. And 4A onwards you will not accept. And B we don't have any restrictions, you can put a B selected. How many states? A plus 2, 5 states. Yeah, B state. See, the question will be very easy, straightforward. Even previous question you can answer directly 3 plus 2, 5. Correct? You don't need to design it because you require the maximum 3. So this will require 3 plus 2, 5 states. To understand the 3, you require 4 plus 1 addition. The language estimate parameter, PDA, DPDA, LBA, Turing question. All questions you should have the idea. One question you are able to see here, then other questions you can infer, you can easily understand. The language estimate parameter is classified as, right? The regular set denoted by the regular expression a plus b. Okay, they're talking about a plus b. What is the specialty of this a plus b? Even if you have expression as a plus b, what is the corresponding language? This is just a comma b, right? I know what it contains. They're talking about the language contains epsilon. Do you have any epsilon? No. Language does not contain epsilon as a member. Yes, will not contain. May or may not contain epsilon. There is no may or may not because there is an expression, right? Information is insufficient or insufficient. You have only A and B, right? Epsilon will not be there in the language. Good. Easily answered. Epsilon not belongs to L. Context-free languages are not closed under. CFLs are not closed under. Union closed, right? Concatenation is also closed. Intersection of two CFLs need not be CFL. You are aware of it. Not closed. Homomorphism closed. Substitution is also closed. Only C is the right answer. So you can observe that block questions will be very easy. Only the thing is to have an idea. In GATE, you have 2 to 3 mark, 2 mark questions may take 5 minutes, 4 minutes, but here every question will take less than 1 minute. Which of the following language is accepted by Pushdown Automata? A star is a regular, right? It will also accept A parent, B parent, DCFL, we know it is also accepted. This is CFL but not DCFL, it is also accepted. So all of them, correct? All are CFLs, but this is a regular, not regular, DCFL, not DCFL. All are CFLs. This is AS, sorry. What is the language generated by the following grammar? Okay. We'll go slowly as not well right now. We'll continue the session, we'll complete the TOC and CSE. See A plus B, 4 plus. Have you seen the questions? You will not see the difficulty. So AS, BS, ARB. You are aware of this? AS, BS, or A. If you have it, you will get languages A plus B. Epsilon if you have A plus B whole star you have. In place of epsilon you have either A or B. In languages A plus B whole plus. At least one A or one B will be there. That will be a Turing recognizable language is a superset of. I'll give you a time. Sometimes read the question properly to answer it. Anyone? Turing recognizable languages REL, right? REL need not be superset of even regular. You're saying superset of everyone. How can be that? See, REL can be B star. B star is also REL. This can be A star. Any relation? The B star can it be superset of A star? No. B star is REL. Reconstrainable language, CF and regular everything. This B star any relation with that A star? No relation. If you're saying superset, that means you are giving a different meaning. This is actually the set of Turing recognizable languages. That is different. The languages is a superset of not one regular language, or superset of set of or regulars. This is how you can answer it. Or set of all CFLs. One CFL, one REL you can't relate. One REL, one regular you can't compare. So this is not going to be any of the answers. Okay. The question, in case if the same question comes, okay, maybe you can choose the D, but that's the wrong answer. With regular language, you cannot say superset of another regular language. Got my point? If you want to say superset, here set of all recognizable languages. Here superset of set of all CSL, set of all CFL, set of all regulars, then all of the above. So there is one more here. Here set of should be there. Set of recognizable languages. Here set of should be there. That's right. Next one. Which of the following statements is true? I hope you are able to understand about type of questions. Do not give much effort on the depth. You need to cover a lot of concepts, but in breadth. The B is the right answer, right? If a language is context free, it can always be accepted by DPD. No, it always accepted by PDA. So here deterministic PDA is there, that's why it's wrong. Union of two CFL is CFL because CFL is closed under union. Intersection of two CFL is CFL. Oh, intersection. No, need not be CFL. Need not be CFL. The complement of CFL need not be CFL again. So only second option is right. So if you see that any question that you are reading, it should be less than a minute. C programming language is which one? I've seen it is a 1 mark question of GATE, right? Most of the BARC questions also will see the same way. C language is context sensitive language. It is not a context free, but its syntax is context free, and its tokens are forming regular language and parsable by Turing machine, but only word is wrong. We don't have the only word here. Parsable by a TM is correct segment. The syntax is verifiable by a Turing machine. Yes, that is true, but only word is wrong. Which type of grammar is not classified by Chomsky? Type 0, type 1, type 2, type 3 also classified. So none of this. Great. The question is right, A power n, B power n, C power n, D power n plus 1. There is no m. There is no m, but still it's fine. What is this language? Yeah, right. DJs, why it is C? Is it regular? No, right? It is neither regular nor CFL. Now, all of them, right? It's not a CFL actual language. It's a context sensitive language. Right? So A, B, C, D all requires the count that is n. It is not regular as well as not CFL. But in the same question, they ask something like this. Then answer is something different. Right? You can compare B with A, D with C. This will be CFL. In fact, it is DCFL also. This question is different. Which one is the right answer? Not more than 3 years. Not more than 3 years means, okay, I think stays missing. Not more than 3 years. Correct. The final states have listed. So this is the right answer. Zero year accepted, 1 year, 2 year, 3 year, it's NFA. If third year comes, there is no path, means it is invalid string as per the non-deterministic finite automata. This one does 1 year, only 1 year, right? A before year, after anything, exactly 1 year. This one is containing a, and it is only 1 year, here containing a. Number of is exactly 1, number of is at least 1. Here number of A at most 3. Here that's a different problem. A, B, V. So kind of the language accepted by PDA is type 0, 1, 2, 3. 3 is the regular, so 2 is context-free language. CFL, this is CSL, and this is REL, is regular. Similar to the previous question that we have studied now, we have a regular expression which is A plus B whole plus. Now that language represented by this expression contains epsilon, will not contain epsilon, right? Does not contain epsilon, that's correct. May or may not contain, that's found away. Information is insufficient. Similar data exactly. Previously A plus B was there, now A plus B whole plus. But answer is now A. So B does not contain epsilon as a member. It is not having epsilon. Another easy question that we have here. A plus B whole star followed by double A plus double B. By looking at this expression, you should know what it does. Is it ends with double A or double B, start with double A or double B, or contains at least one occurrence of double A or double B? All strings have even length. What is it? What? What was saying was? A plus B whole star followed by double A plus double B. By looking at this expression, you should know what it does. Okay. Hello. 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 What do you know? Hello. 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 Am I audible? Am I audible now? Answer that just fell down. That could tell the reason why the audio is. Every expression is ends, right? Ends with WA or W. How do you see first? Or W? And it is one occurrence of W or W. One occurrence means either uh, double E you can have or double B you can have. But yeah, after that, double E you can have. B can hello, 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 hello. 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 No, it's fine. Context-free languages are not closed ended. So you can remember the CFLs closed or not closed is one of the important topic, right? You see a lot of questions, even some of them are previous bar questions too. CFLs are not closed under a reversal. We are aware. Intersection with a regular is also closed. The CFL intersection with regular is CFL. CFLs are closed under union, but not intersection as well as complement, and not closed under complement. What about the 𝐂𝐚𝐿 star? It is closed. If you want to remember the CFLs, what are closed? Union, concatenation, 𝐂𝐚𝐿 star, 𝐂𝐚𝐿 plus, substitution, homomorphism, inverse homomorphism. If you are looking at not closed, You will see intersection, complement, so on. And subset not closed. One of these Z type. Which one you will choose? Really not well today. We have practiced a lot of such questions, right? This is A power n, B power n. They say S derives A as B or epsilon. Languages A power n, B power n, where n is greater than or equal to 0, obviously. They say S derives A as B or AB. Then languages A power n, B power n only, but n is starting with 1. This n greater than or equal 1, you can also write n greater than 0, like second option. The other one is A star B star. This is different. In fact, it's regular, you can write regular grammar or context. Read the question. Theoretical questions may take time. No, it's not ambiguous in general. That's unambiguous only. Is the answer? They're talking about DPDA and NPDA. Every language recognized by DPDA is regular. Every is a problem. In place of every, if you have a sum, that would be the right answer. Some languages recognized by DPDA will be definitely regular, but every is wrong. A non-deterministic PDA can recognize some languages that are deterministic. That a deterministic one cannot means what? Other than the DCFL, you can do it, right? Which are not DCFL also you can do it. Yes. A deterministic PDA and non-deterministic PDA recognize the same class. No, they are different class. The DPDA does DCFL's class, PDA class, CFL's class. A context sensitive language can always be recognized by a PDA. No, right? LBA is the right answer. CSL may or may not be recognized by PDA. B is only the right answer. A Turing machine with a single tape and infinite length in both the directions differ from a standard Turing machine in that infinite tape is there, infinite length is there, single tape is there, and both directions it can move. How it is different from single tape Turing machine? It can recognize larger class, it has the same power, can only recognize CSLs, it can simulate PDA. What is it? Same computation power. The various types of Turing machines are there, all of them will have the same computation power, only their configuration is different. A power n, B power 2n, C power 3n. Like there are many languages, not only this. Even you can take this one, or you can take B power n plus 1, C power n plus 2, or you can take A power n, B power 2n, C power 3n. And all, even not only this, there are many other languages too. They're all context sensitive language. They are all context sensitive languages, but not context free. Is right. You have seen this, a pattern of the the TOC. In TOC, what do you learn here mainly? Like focus on straightforward, like languages, learn them easy ones only, not difficult ones. There is no construction oriented, only the number of states in a minimum DFA. They may ask you a simple questions are two. Regular expressions they will give you, and they'll ask the strings generated or not generated. Context free grammar, they will give you ask the language. Maybe sometimes regular grammar, that is very easy. And a lot of theoretical questions, simple theoretical questions. Okay. Enclosure properties, union, intersection, difference, basic questions there. Some basic pumping lemma questions can also be asked here. Now, in compiler, the process of mapping identifiers to memory locations is handled by whom? Is identifiers to memory locations that is handled in symbol table. Symbol table will have the all data. Mapping is, like in symbol table you will have identifiers, like maybe if you have written int x is equal to 10, so x is there, and this is what, let's say ID 1, and corresponding location address maybe let's say 1000. This address is handled by the symbol table. Which of the following is true for predictive parsing? Again, easy questions. Whether COC or compiler or any other subject, We'll see straightforward questions here. The easy question, right? All the concepts are covered at one place. It uses stack and parsing table. It requires left factoring and elimination of left recursion. It requires unambiguous grammar. It can parse only relevant grammars. All of them are true. Predictive parsing is nothing but LL1 parser. Which phase of the compiler performs constant folding? Very easy again. So here one point is missing. Which point? They should use the code optimization, but in the intermediate code generation also you have the part as a code optimization. We don't treat as a code optimization as separate phase, only the one which you can use intermediate code generation. The code optimization can be part of intermediate code generation, you can use it. But the vast phase of the compiler, that intermediate code can have the code optimization, the algorithms to do it. But you know, they should have used the another word, code optimization, rather than intermediate code generation. That is the best one. But during intermediate code generation only that happens. The main disadvantage of using a top-down parser over a bottom-up parser. You want disadvantage of top-down parser. Yeah, good. A is the right answer. It cannot handle left recursive grammars. Because LL1 grammars are not left recursive grammars. Correct? It requires backtracking for all cases. No, only some cases it requires backtracking where you have the common prefixes. Okay, all that's a wrong here. Some cases only it does. It construct a parse tree, so does not. It's a wrong here. It is slower than, no, it is faster than the bottom parsing, obviously, because it has easy method. The number of states required to construct LR parser for a grammar is generally more than SLR, same as LR0, always finite, or for any context-free grammar. Which one is? Think about it. General type of question. LL1, LR1, you cannot compare. As you know, LL1 do not maintain the states. SLR1 and LR1, can you say more than SLR1? No, sometimes it can be equal, correct? LR0, LR1 may not. So always finite number of states for any context-free grammar that you take. LR1 means CLR1. No one is answered so far. I've already answered still. No, LR0 is different, Priyanka. See, LL1 no relation at all, correct? So we have LR0, SLR, LELR, and CLR. We know CLR only called as LR1. If you take number of states here, these three are equal, but this one less than or equal relation is there. So more than SLR is wrong because it can be more or equal also. The same as LR0 is wrong. Always a finite for any context-free grammar that you take, finite number of states are guaranteed. Because we never have infinite number of states when you design in the DFA. Can have an infinite loop, that's a self loop will be there in the graph, but number of states always finite. Consider the following grammar. This grammar is suitable for which parsing? LL1, LR0, operator precedence. What is it? It is not suitable for LR0, no doubt. Operator precedence parsing, if you apply it, you should have no null productions, right? That's a problem. LR0, why we will fail? Because you will have SR conflict, shift item, reduced item in the first state itself. Here S derives dot ASP and S derives a dot. This two produces SR conflict in LR0. Operator precedence passing, it's not suitable because null production is there. Two consecutive non-terminals should not appear, and null production should not appear, but this grammar is having. Recursive descent parsing, if you want to implement here, there should be a token so that by reading A you can, or by reading somebody you can change the function, or you can write a procedure. And recursive descent also, but non-recursive descent is right? LL1 parsing is fine. The LL1 can use the non-recursive descent parsing technique to do this. Which one is the 3 address code? Which one will be the 3 address? Sound come again? Hello? Hello? तो साउंड कम लग रहा है क्या? स्टार्टिंग का वीडियो देख के आया क्या? this is just like same as, right? Both are same. This one is just like x is equal to minus y. This is also fine. This is also 3 address code. But this one is not a 3 address code. You have to take this separately. You have to take this separately, and you should assign this value to this value. And you need maybe 3 instructions separately to convert into 3 address code. At first y of z, you should have a separate one, and then you should assign that to x. Which data structure is used in handling function calls and returns in a compiler? So which data structure will be used for calling and returning mechanism? Priyanka, that's not a correct format. It is not a. We may write sometimes, but not actual 3 address code. Stack is a very famous one, which helps us to maintain the calling. Using activation records also you can do it. All the activation records can be pushed down to the stack. Peephole optimization is used in. Name itself says that peephole optimization. Which phase will use it? You tell me. The code optimization, right? Obviously it is. Which are applicable for few set of instructions. Which of the following parsing techniques requires lookahead to determine the correct production rule? Lookahead means one token. So one token is there in all of them. This is called as the lookahead. All of them are going to use that lookahead concept. But if you have, let's say, LR0, this cannot use the lookahead mechanism. D is the right one. While construction is different, this is about the parsing technique. To determine the correct production rule, I want to know which is the next production rule. Then this one will help us based on in LL1. Suppose I have S derives A or AB. AR, let's say BC. Now, if my token is A in the input, then I can find out. I can choose this grammar production to take the substitution. Similarly, SLR, LLR, whenever some reduction happens, they will help us. The role of lexer in a compiler is to check for what? Syntax errors, convert source program into sequence of tokens, generate object code, optimize intermediate code. Which one is it? Hello? 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 Mic तो on है. Mic off हो गया? The role of lexical analyzer in a compiler is to check for what? Syntax errors, converts the source code into sequence of tokens. भाई सारा है ना यार, बीच बीच में ये क्या हो रहा है? SR conflict occurs in which type of parser? So, shift reduce conflict is there in which parser? Conflict happens in LR0, SLR, LELR and CLR. Here this is LR1 means CLR only, correct? LL1 we don't have a conflicts. What we have the N conflict or T conflict, not this SR conflict. In LL1 we have a different one. Which optimization technique replaces expressions with the constant values? So there is an expression that will be replaced with the constant values to improve efficiency. Or which one of them? Like you have some expression here that should replace with some value, let's say 3. Like I may have here 4 minus 1. That is an expression, it will be replaced with a 3. So what kind of this is here? Loop unrolling, dead code elimination, constant propagation, register allocation. Replaces an expression, expression with the constant values, not a constant folding too. I may have something with, let's say, x is equal to y plus z, and here z is equal to z. Now this expression we are replacing with a constant value. So this 2 will be replaced here. So what kind of propagation it is? It is a constant propagation. Previous one I was explaining for constant folding. When you are doing x is equal to let's say 4 minus 1, then this one you are replacing with a 3. It's called as constant folding. There also similar meaning comes, but your expression you are replacing with what? Constant only. But as per the options, you are going to change your answer. Correct? This is a constant folding, this is a constant propagation. The DAG representation compulsory is used to identify common sub-expressions, eliminate loops, remove syntax errors, optimize parsing. Which one is the right? It identifies common sub-expressions and also eliminates, right? DAG special purpose is for eliminating common sub-expressions. Loops we don't eliminate, syntax errors we don't remove. Optimizing parsing, that is not having any. This is not there in gate, but right now you may be seeing in BARC. Okay. In a 2-pass assembler, the first pass is used to generate the machine code, build the symbol table, allocate registers, perform. There are 2 pass, right? First pass assembler is different. Like compiler only we have 2-pass compiler and so on. First pass, second pass. About assembler they are talking about. In first pass, while scanning the code, what it does is it builds a symbol table here. While scanning the whole code. And if you want to patch any addresses that are not done in first pass, second pass it does it. Okay. So it's going to build the symbol table during the first pass of what? And machine code will be generated at the end of the second pass, not the first pass. Okay. Generating machine code happens at the end, after second pass. But it cannot generate whole machine code in the during first pass. It does few, but not all. Second pass, after identifying some of the addresses which are not identified during the first pass, will be patched later. It should be. So this symbol table is different from the other symbol table which you see in compiler. Which of the following is true about operator precedence parsing? It can handle all CFGs. It cannot handle non-terminal operators. used for ambiguous grammars, requires backtracking. Find out. Yeah, and बहुत लोग को ये प्रॉब्लम हुआ था because of shift to, right? Anyhow, need to look for alternates if you want to take the decision this year. In case you have no other option, then better prepare for the gate in case if you wanted to. If you're getting above 50 marks or above 55 marks in shift 1 or shift 2, especially shift 2, then you can take the admission somewhere if you are interested to do MTech in any college. Yeah, it can be used for ambiguous grammar, that is a specialty of operator precedence parsing, especially the grammar like E derives E plus E, E star E, or E minus E, something like this. You can have a lot of expressions which depends on the different parses. Same expression you can generate with a more than one parse tree, but operator precedence grammars can help us to do uniquely with the help of precedence rules. The primary purpose of intermediate code generation in a compiler is to, what do you do? Intermediate code generation, improve execution speed, provides portability across machines, perform register allocation, eliminates runtime errors. So execution speed depends on optimization. If you optimize the code, then it happens. But intermediate code purpose is to provide the portability. That same intermediate code you can use and run on different machines. Okay. So B is the right answer. A is for code optimization. When you do that optimizing the code, then you can increase the speed, execution speed. Which statement about LR parsing is incorrect? Go ahead. Oh. C is right, but D is not framed properly. LR parser can recognize a larger class. This is true, right? LR parsers use a stack to store the states. States can be stored in the stack, that you are aware, using during LR parsing. SLR parsing is more powerful. It's not actually more, it's a less powerful. You are aware it is a false. And canonical LR parsing requires sometimes more states, sometimes even equal states compared to LR parsing. So this one is a false statement. Instead of more, you could have used more or equal states, correct? So you have to choose only one. So I'm changing the statements. CLR parsers requires more or equal states than LLR parsing. Otherwise, this is also false. To make it true, just I change the statement. A register allocation in a compiler is performed during which allocation of register assignment does during code generation with the help of even optimization technique too. So code generation, during this phase, the register allocation happens. Your The intermediate code will convert to assembly code. That time the code generation is responsible. The primary advantage of just-in-time compilation, it is not there in C, C++, but Java, you will use this just-in-time compilation. For what purpose? To reduce the compilation time, to improve the runtime performance, it allows the need of an interpreter, it allows execution of on any processor. Anyone? This is related to Java type of, there you will use the interpreter and compiler, but after interpretation the code is portable, but when just-in-time involves that compilation is required, so during runtime the compilation happens, so it is trying to improve the runtime performance, not the day. It will not allow execution on any processor. It's specific. Just-in-time is about compilation. It will not allow you to execute on any processor. It's specific to the processor, like just compiler. Okay. Because in runtime, performance will be increased. So this is going to happen after interpretation. So this, have you seen that the BARC, how the questions are there? Just go with the questions which are relation based, definition based, comparison based, right, formula based, and most of the questions should take less than a minute. Then only you can solve a lot of questions in a given time. Okay, do not worry about all the algorithms. It is not going to be, right. You may not require most of the questions pen and paper in the BARC exam, but BARC interview it is different, right. BARC exam is just going to filter the people, but once you go for interview you should go with the very different strategy. At that time we'll help you, like whoever shortlisted for interview will be there to help you. In case you have done well in BARC exam, then you can also start preparing for interviews, and we'll connect after the exam how to prepare for interviews too. Okay, thank you so much for joining this session. Bye bye. Is anybody wanted to discuss anything? Those people who are not connected and you wanted to talk directly, then you can drop a message to me. I'll discuss with you. Okay. Thank you. Bye bye. Yeah, Tarang. You can drop a message. I'll talk to you, Tarang.